Analyze and graph. Shouldn't be too bad. Lindsay, where's the vertex? You want to think about that a little longer? No. Pay attention. Y's, X's. Now there was a problem with the first pair that you gave me, in that you gave me Y first and then X. There you go. Negative 3, 4. Remember you got to change signs and read parentheses, kids? And X's are found with X's, Y's are found with Y's. That's how it works. There's your vertex, okay? Daniel, can you give me P? No.
Oh yeah, I was going to say it and then
How'd you do that?
there's a 4 in front of it.
Yeah, there's a 4 in front of this thing. You're supposed to think 4P equals negative 8. So there's your P equals negative 2. Bryce, that mean anything to you? What's it mean to you? Kinda. How it opens, right? It's gonna, stuff like that. No, I didn't talk about this. Oh, we're still in the sideways parabolas, aren't we? We never moved on. So we know this thing opens. How's it open, left or right? Left. And we also know stuff like where the directrix is. I think we have everything we need to graph. We do. So back 3, up 4. There's our vertex. This P, it tells us how it opens, and it tells us how to find two other things. It's the distance to two things. What's it the distance to? That one? It's the distance to focus. And the D word? What D word? I know a lot of D words. Directrix. So here's my vertex. P happens to be negative 2. Where's the focus? If the vertex is at negative 3, 4, negative 5, 4. About the directrix? Negative 1. It's right there. That's that imaginary line. All we need now are the coordinates of the lactus rectum, or sorry, the endpoints of the lactus rectum. How do you find the endpoints of the lactus rectum? Might have to look on the first slide on the front page of your notes. Plug in an x coordinate of the focus. So y minus 4 squared equals negative 8. What's your x value? Negative 5 plus a 3. It's really hard to read. I haven't woke up yet, but that's y minus 4 squared equals negative 8 times negative 5 plus 3. What on earth is a negative 8 times a negative 5 plus 3? 16. Now you're in algebra 2. Actually, you're in algebra 2 as soon as you plug that number in. Counteract squaring, how? Square rooting. So I think you'd have y minus 4 equals plus or minus 4. And when you add 4, what are your two y values? 8 and 0. Nope, I put that in the wrong spot. I put that at the vertex, didn't I? That's not where that goes. Where's that go? Above and below the what? Focus. How did I decide where? The what?
How does the 8 and 0 affect the graph?
They are the coordinates right. They are the y values right above and below the focus. Might have to add a little bit to our notes on that. It goes back to this front page. That drawn in segment is called the lactus rectum. It's an aligned segment that passes through the focus. That's why we plug in that x value into the original equation of the parabola, because it'll give us the endpoints on the parabola. So the endpoints of that segment exist on the parabola. Yeah, that's how I feel right now. That's how you know. It just goes right through it. Hey, cool. We're done with the sideways parabolas. So now we're going to move to the up-down parabolas. There's some extra videos there you can watch, although I don't know if they're actually valid anymore. Those video links were from 2016, so I don't know if they're still even valid on YouTube anymore. This is day 2, parabolas that open up. When you were in Algebra 2, you did stuff like this, y equals x squared. I hope you remember doing that, because you did. Maybe a transformation happened. Maybe it was like x minus 4 squared. How's that shift a graph? Not to the left, to the right. Things in parentheses lie. And of course, there were other transformations that were done, but we're using a more standard form here. The equation's actually written down there, but we're going to use the form x minus h squared equals 4p times y minus k. And it's really no different than what we did yesterday, except today they open up and down. So if you were, say 50% yesterday on sideways parabolas after doing a couple of vertical parabolas, it'll get there. It will. Only thing that's changed is what's squared, right? Kind of locations. Literally, all that happened was x and y swapped spots. So did h and k because they're related to x and y. But everything else is the same. We are going to do a little bit something different. Because these are vertical parabolas, and only because of that, when we find the coordinates of the lactus rectum, we're actually going to be plugging in a y value. So we're going to plug in y values to find the endpoints of the lactus rectum. There's some typos on the notes there in 2, which we'll fix real quick. Uh-oh, snotty nose, Taylor. That's how it starts. know who wrote these notes or what kind of drugs they were on, but there's a lot of mistakes in them. Right there. That's a mistake. You think that makes any sense? If you open up, P is negative? No. What should it be? Positive. How about if it opens down? Negative. You know. All right. We actually are not going to do this one right now. We're going to come back to it because it's not an up-down parabola. All right. The sideways parabola. We'll come back to it. Try that again. Well, this one gives us some information we've never encountered. The parabola has a vertex at -4, -7, and a directrix at y equals -8. Now, you may not know what to do with that information right now, but can you start graphing it? That's where you should start with this stuff. You graph everything they give you, otherwise you're not going to stand a chance. If you're that kid who sits there and says, I don't know what to do, I'm just going to ask you why you're not graphing it. You graph what's given. And everybody in a room can graph. It doesn't have to be pretty. So there's -4, -7. That's my vertex. What else you know? Directrix. What kind of line is y equals -8? Horizontal. What's cool is it's just 1 unit below, isn't it? I don't know if it's cool or not. It really doesn't make anything any different. There it is. Oh yeah, that help you figure anything out? Taylor says P. Brent says it opens up. They're both right. Parabolas don't need directrices. That's not a word. What do they eat? What do parabolas eat? Foci. Right? Foci. Or quadratic formula. It's probably baby parabolas. That's probably a joke. What do baby parabolas eat? Quadratic formula? No? Tough crowd this morning. Tough crowd. So the directrix is 1 unit below the vertex. Where's the focus?
1 unit above.
1 unit above. So it would be at what? -4, -6? Now all I need is 2 other endpoints here and here. I need the coordinates of the lactus rectum. To find that, I need an equation. So I need to be writing an equation. But shouldn't be too bad. Up downs is where x is squared. What can I plug into h and k? The vertex. So x what? Plus, minus, plus what? 4. You look at the vertex, kids. You don't look at me. You look where it talks about the vertex. I'm going to leave this 4p spot blank for a second. Why what? 7. How do I figure out the number that goes in front of that thing? P is 1, right? So 4 times 1. There's your equation. Now, these are not sideways parabolas. These are the up-down parabolas. If you plugged in an x value of the vertex of the focus, it would just return the y value of the focus. So that won't work this time. You need stuff here and here. X is already known to be, y is already known to be -6. That's going to stay the same, so that's why you plug in your y values. Because you're going to be on this horizontal line where y is -6. So we're going to find the LR by plugging in y. Not to mention the fact that you need 2 of them. Only plugging in y is going to guarantee you 2 answers. So x plus 4 squared equals 4 times, what's the y value of the focus? -6. -6 plus 7. What is that 4 times that -6 plus 7? It's 4, right? What's the square root of 4? Plus or minus 2. Alright, so we have 2 x values. What are they? -6 and -2. Go back to your graph. And we just got to stay right there lined up with the focus. We have something at -2 and we have something at -6. What questions do y'all need to ask? Or is there just so much random information and that's what makes it difficult? There's a lot of things you got to figure out here. There are. This one won't be near as hard. Doesn't talk about graphing. Parabola has a vertex at -4, 8, opens sideways, and passes through 8, 12. Write the equation for this parabola. Open sideways. What's the form? Brenton says y first. So? Anything you can replace, this is backwards, k, h. What can you replace k with? 8. How about h? Y minus 8 squared equals 4p, x plus 4. Normally I would talk about graphing, but there's actually zero need to do this. What we did is we used that point. Don't I have another one? What's the other point give me? I honestly did not understand either one of you, but I don't think you were right.
I don't think I was right, so.
It gives you an x and it gives you a y. Nobody cares in your final form if your equations have x's or y's in it, do they? All final form equations have x's and y's in them. Well, you can't have a p, so Brenton, what are you thinking?
Plug it in.
You plug them in. They're a source of substitution. That's all they are. So we'll put an 8 right there. Put 12 right there. We'll do a little math. 12 minus 8 is what? Let's go with 4. 4 squared is? 8 plus 4 is? So 16 is 4p times 12. Or how many p's? 48 of them. What's your p value? One-third. 16 over 48, kids, is a third. Then you have your equation. Plug that p-value back in. 4 times a third being 4/3. X plus 4. So that was pretty easy. This stuff is actually used primarily in communications, although there's a lot of things. But satellite dishes are called parabolic dishes. They are. Go look at them. You'll see it. They have a little receiver on the end called a transceiver, where all of the energy of the parabola is focused. Newer car lights might not be because they switched over to LED, and a lot of times they have built-in reflectors, but if you ever go look at an old headlamp, they were parabolic in shape because they would ensure that all the old light bulbs, they didn't emit light straight. They emitted it from all directions. So they would ensure that all light kind of at the bottom of the bulb was focused right back out the front of the car. So even headlamps, the assemblies, they're parabolic. A lot of things are parabolic. But for your generation, this is probably the biggest deal right here. It's about cell phones. A lot of times in between cellular antennas or the towers themselves, they will link the towers together with antennas instead of running hardline cable between them. Or sometimes they just do it for backup purposes in case the fiber gets cut or something like that. But all your cell towers are linked through their own little wireless network. So you're going to build what's called a wireless bridge between two cellular towers. You need to mount the transceiver at the focal point of your parabolic dish. Parabolic dish is 4 feet wide and 1 foot deep. How far from the vertex should the transceiver be placed? Now, most of these things are sideways mounted, which is fine, but I would recommend you just go ahead and do a regular up-down parabola. Make it easier. And things are really easy if you place them in the right spot of the XY axis. Where do you think the vertex for this parabolic dish ought to be if you place it on the XY axis? Zero, zero. Now, my parabolic dish is 4 feet wide, so I'm going to go out 2 units on the x-axis. It is a foot deep, so I'm only going to go up a foot. This is my parabolic dish. Now, I don't know if I talked about this yesterday or even just this morning. A transceiver is the focus. That's where all the energy of a parabolic dish is focused at. What a transceiver is. Well, this isn't going to be that bad. What are the coordinates of the vertex? 0, 0. Anything else about this graph? Any points that you know exist for 100% certainty? You don't know about 0, 1. You know about 2, 1. That was a firm point based on how I graphed it. And you also know about negative 2, 1. Anybody know how that's going to help me? What's that? Gives you an x and y. You can write an equation of this thing. It's your standard up-down parabola. What's the default form you use? What's squared, the x pieces or the y pieces? X pieces are squared, so x minus h squared equals what? 4p times y minus k. Now, this is really easy because of the way you chose to draw this thing. Well, the way I chose to draw this thing, it makes life easier because h and k are just 0. So we get to use the easier form, x squared equals 4py. Now, you got 2 other points that you can play with. You want to use the negative 2, 1 or the positive 2, 1. Yeah, why not use the positive 2, 1? It's usually easier to work with. So 2 squared equals 4p1. The whole point of doing that is to get you p, because p will tell you where to put the focus because of its definition. So anyways, you have 4 equals 4p. What's p? Well, that's perfect. If you know what the definition of p is. Haley Brooks, what's the definition of p? It's not necessarily the focus. It's the distance from the vertex to the focus or directrix. It's got 2 pieces to it. So we know that the focus is 1 unit from the vertex. So this little simple problem, just set it up with your transceiver right there. And it's at what, 0, 1? Yeah.
So you said when somebody said that 0, 1, and you said you don't know that point for sure, but we have like 2 other.
We had not graphed it. You're trying to make a pattern out of the easiest example I could come up with. Don't do that. Don't ever do that. If you actually go look at most satellite dishes, if you actually look at them, the focus is actually out here somewhere. Very, very horrible diagram, but usually the transceiver is outside of the parabolic dish itself. Usually, okay? Let's hold on. Let's go back to that example that I didn't do. So this guy has a vertex at negative 2, 3. Focus at 0, 3. And we're just supposed to graph it. No, we're also supposed to find an equation, aren't we? That won't be too hard. Is it an up, down, or a left, right? Left, right. So what's squared? Y is squared. So what's our form? There you go, y minus k squared. X minus h. So I guess we'll have a y, take away a 3 that's squared. 4p. I can find p. This is p. What is p? -2. Oh, no, no, blah, blah, I'm retarded. It's +2. Because it's opening how? To the right. And then x plus 2. So here's your equation, kids. Why don't you guys find the LR? All you got to have is the x values. The y value is known. Sorry, all you got to have is the y values. The x value is known. Sideways parabola, you're going to have a vertical line segment pass through your focus. I know you don't like it. If you don't like it, if you truly, truly hate it, go home and take a hammer to your cell phone, television. For that matter, your car. Anybody got it yet? 7 or what? Sure about that one? 7 -1. I'm not going to write that on the board. I'm not going to work it all out. But to find the focus, because this thing is opening sideways, we plug in the x value of 0. 0 plus 2 is 2. 8 2s is 16. Root of 16 is plus or minus 4. We're going to add 3 to plus or minus 4, and we're going to get 7 and -1. And those two y values are points that we plot above what? The vertex or the focus? Focus. And directrix is not that big a deal. So it personally doesn't bother me if you graph it or not, honest with you. It's just not that big a deal. I mean, nothing in the real world has an imaginary line behind it. I guess it could, but yeah, you need to talk about this. Here's the last example. Analyze this equation. X squared plus 4x minus 4y equals 0. So you are supposed to graph this thing. I probably won't walk you through graphing it, but you need to analyze it. What's squared on this thing? The x's or the y's. So your goal is probably to make it look like x minus h squared plus, equals 4p times y minus k. Because it's the x's that are squared. If it was the y's that were squared, you'd do it the other way around. But that's your end game. Get there. Now I have a massive hint here. Complete the square for x. I also know that I want stuff with y on the right-hand side. So this stuff with y needs to jump over here. Now I don't have the steps down for completing the square. First step is to divide out a, but a is 1. Divide a, and normally we'd say move c to the other side, but we'll just say move other stuff to the right-hand side. That's basically what step 1 is. Remember what step 2 is? Take half of b, square, and after you square it, what do? Add to both sides. You know, the Babylonians could do this 6,000 years ago. They didn't screw up because they were working on clay tablets. All right, so we're going to take half of b. What's b? 4. Take half of it, you get 2. You square that 2, you get back to what? 4. You add 4 to both sides. Congratulations, you created two things as factor. How's the left-hand side factor? X plus 2 squared. How's the right-hand side factor? 4 times y plus 1. And that is something that you can graph. And I'm not going to go over how to graph it. That's the gist of it. And you now know everything you need to know to do your homework. Well, you've been instructed everything you need to know. The do you part, well, that's up to you. So tomorrow we'll go over your homework and then we'll talk about ellipses.